Hello there. We are going to look at our second transformation. Now we are going to look at reflections. So let's go right into our definition. Alright, when we are doing a reflection, points or a shape are reflected across a line to create a new shape, or obviously new points if we're working with points. And the way that we write this out is we have a big R here standing for reflection, and then we have an equation of the reflection line down here. So we either have y equals some number, or we have x equals some number. There's one exception to this, which I'll talk about on the next slide. But generally, we will have big R, little y equals some number, or we will have big R, little x equals some number. The one exception to this is if we say the x-axis or the y-axis, and these can be translated into the format that we just saw. If we see x-axis here, this means y equals 0. It's kind of backwards because it flips which sign or which variable we have, but the x-axis is the line y equals 0. The y-axis is the line x equals 0. So whatever we have, we need to translate into one of these two equations here. That's only for the x-axis and the y-axis. A lot of times you will see just a regular equation to begin with, for instance, x equals 4 or y equals -2. Right here, I just want to give you an example of what we would do if you came across a problem that would say reflection across the x-axis. We would just want to write this as, we'd still have our big R, and we would turn this into x equals 0. And while this wouldn't be our answer, it's a step in the right direction that we would want to take. So let's take a look at a couple example problems on how these problems would actually work. Alright, so we're given a shape right here, and we say that we want to reflect across the line y equals 2. Well, the first thing we want to do is we want to graph this line y equals 2 because we want to see where our line is that we're reflecting across. So if we have y equals 2, you should remember that y is up and down. Y is up and down, and x is side to side. So since y is up and down, we're going to go up 2 spaces. Mark our point right there, and then we're going to make a horizontal line all the way across at 2. Generally, for the problems that we are seeing, we're either going to have a horizontal line or we're going to have a vertical line. You may see diagonal lines later on for reflections, but for right now, we are just going to be dealing with horizontal and vertical lines. So we've got our line of reflection right here. That's what this dotted line is, and I like to have it a dotted line so I don't mix it up with either of the axes. But we have our dotted line of reflection right here. Now what we're going to do is for each point, we're going to figure out how far away that point is from the line, how many spaces. So first off, this point right here, you see it's pretty close, and it's about halfway between this space and this line right here. So I'd say that this is 1/2. It's got a distance of 1/2 between the point and the line right here. So we are going to go the same distance down below. So I'm going to go halfway between this point and between these two marks right here, right over here. So I'm going to go down the same distance that I have already. So it's not perfectly accurate, but we should have the same distance between this point in the line and this point in the line. So I want to do the same thing with these other 2 points up here. So the second point right here we see is a full distance between this point and this line. So then we're going to go the same distance right here, down, right there. So now both of these have the same distance to the line. I'm going to make this top point a little bit darker. And if I count, I see that this top point is 2 spaces from the line, and so then I'm going to stay here and I'm going to go down 2 more spaces right there. So now I have my 3 points down here, and I'm going to connect them all with lines. So now it actually looks like my shape has been reflected across this line. It's been flipped down. It's kind of like a mirror. So let's take a look at one more example here. Here we've got 4 points, and we're asked to reflect across the y-axis. So I'm going to translate this into an equation, and so that'll be reflected across x equals 0. So we've got reflected across x equals 0. So that's actually going to be this middle axis right here, because x is side to side, remember? So we're not moving side to side at all. We're going to reflect across this middle line right here. So I added my dotted lines in. Now this first point right here, this is right on the line. So the distance between this point and the line is actually 0. So I'm not going to move that at all. That's going to stay right there. That's going to reflect in the same spot that it already is. This bottom point right here is about a distance of 1 right here. So I'm going to go another 1 over to the left. And we have our new point right there. Moving on, over here we see we've got a distance of 1, 2, 3 spaces. If we count the bottom down here, 1, 2, 3 spaces. So I'm going to go 1, 2, 3 spaces to reflect across. And then the top point up here we see we have a distance of 2 spaces between this point and the line. So I'm going to do an additional 2 spaces from the line to the left. Alright, so now we have another diamond right there, and ideally these would be exactly the same, but obviously they're a little bit different because my drawings aren't perfect. But if you were to do this perfectly, they would look exactly like mirror images of each other.